Welcome to my talk. Today we're going to talk about code archaeology. So, that's me. My name's Arthur, or Art, take your pick. This is usually the slide where I explain that I am a developer and not a psychologist, and while you're about to hear a talk that's entirely about brains, I work with computers. Instead, this is the place where I'm going to tell you that I work with computers, and have for over 20 years at this point. For many people at this point, have given me money to work with computers, which is kind of insane when you think about it. But I like thinking about brains. It's super important to me. And this talk is filtered through my lessons of how to work with other people's code and what I've learned about human brains and how that can actually help us. So today we're going to talk about them. This is the latest place to pay me to work. It's Avature. You've never heard of it. It's in Omaha, Nebraska, which is where I come from in the United States. But they pay for me to be here, so they get a slide. Let's start, like all good talks, with a story. A number of years ago, at actually my current job, I was working on a project for a client. And just for the sake of anonymity, let's say it was a project for bingo, where you could place bets on bingo cards and earn money off of this. This code was, how shall I put this, bad. There were 9 different languages inside of this project. There were files that had been created literally before I'd ever been paid a dime to write software. Like, it was 20 plus years old in various stripes of the application. It was using multiple different large-scale frameworks. The number of libraries it was using in the places where it actually used any libraries at all was immense. And it was extremely frustrating and thorny and awful to work with. The process of actually working through this software took months. And all of this from a system where the lead developer on it assured us, as we took, this was something that somebody else had written, and the client had a falling out with them. And so we took over maintenance of this, and we were going to help them help them lift to the cloud, because it was all running on vSphere in an on-prem RAID situation or on-prem, virtualized situation where their RAID actually had multiple failed drives in it already, but they couldn't quite afford to actually get new ones or couldn't get it authorized. So we were already starting off on the back foot. And this developer, as we took over, assured us, and I have the words to this day, memorized, just said it just works. Literally the first day we had support of that project, it fell, total system outage. That very day, because we believe somebody using IE8 happened to connect to a web page. That really should give you an implication of just how thorny and twisted and awful this software was. But this trial by fire, or trial by jungle, I suppose, really started to make me think about how I thought about other people's code. And I realized throughout the course of this that code is an artifact. It was created by other humans. Even if it was with AI assistance, it was created by other humans for an explicit purpose and to achieve a goal. Now, there's a word for that process of discovering those artifacts. It's called archaeology. And archaeology allows us, as a tool, if we use it, to help us unlock ways to pull our thoughts in better directions while we're reading other people's code, more productive directions. In directions that help us move forward instead of just cursing the names of those who have come before us. Directions that help us sift through what archaeologists call the matrix, which is a fancy sounding name for what is basically just the dirt and the rocks surrounding the artifacts that they're extracting. And this talk isn't just for legacy code either. It's for any kind of system that you don't know how it works. Whether that's moldy bits of Fortran sitting on a shelf that haven't been running in decades, or whether that's something actively being developed and worked on in the modern era, you just don't know how it works yet. Or even for libraries that you're depending on, and you just, for some reason, they're behaving in a strange way and not how you'd expect. These tools and techniques will work for all of those situations. Because let's face it, unless you have a really special job, most of the code you encounter is code you did not write. And once code's in production, it often has a very, very long lifespan. And disturbing it, if you don't know what it does, can lead to some very bad outcomes if you're uncertain of what that purpose is. So today, we're going to walk through a 5-step process of how to do code archaeology based on the actual survey, extract, and analyze form that real archaeologists do. So let's start with mindset. The most important steps in this process come before you ever encounter any lines of code at all. If you've ever seen one of my talks before, I'm sure that you're not surprised by this. You've got to get your mindset right. When you encounter other people's code, there is a spectrum of ways in which you can approach it. And I like to think of the two extremes of that spectrum as what I call Chesterton's fence and the monkey ladder experiment. So Chesterton's fence is a reference to an author, G.K. Chesterton, a British author, wrote a bunch of mystery stories, but famously had a paragraph in a book where he described what I will paraphrase as you come across on a path a fence or a gate that has been placed there. And what he basically says is you have to assume that that has been placed there for a reason, that someone has done this for a reason, for a cause. The flip side, the other end of the spectrum, is the monkey ladder experiment. This is an experiment that has never really been run. It's a thought experiment. And it would never pass an IRB, so you'll never really see it in the wild. But it starts with hanging a ladder, or hanging a banana rather, and then putting a metal ladder underneath it. And then you electrify the ladder, and you release a bunch of chimpanzees into the room. It's great fun, fantastic YouTube, it'll be great. These chimpanzees, they obviously will go for the food and shock the hell out of themselves on the ladder. And eventually all of them will learn you don't go near the ladder. What you start doing then is swapping out chimpanzees in the room. And as you do this, the new chimpanzee will look up and go, banana, and go straight for the ladder. Chimps are generally pro-social animals, and they'll prevent each other from getting injured, so they'll protect this other person, this other chimpanzee. If you keep swapping out chimps in the room, the theory goes that you could swap out the entire room full of chimpanzees, and you would have chimpanzees who had never themselves been shocked, but would all avoid the ladder. And at that point, you could actually unplug the ladder because they've learned through the environment, right? There's become a social norm that you don't go for the ladder. These are the two extremes of this spectrum. And the difference in mindset between them is that with Chesterton's fence, you assume that when you come across something, it has been put there for a purpose, for a reason. And in the mindset of the monkey ladder experiment, you assume that when you encounter something, it is there because of happenstance or because of social norms or because of random chance, not necessarily because of intent. Once you've got that under your belt, the next two things you need to master are curiosity and empathy. And you need to have them preloaded and practiced to be able to be effective at our code archaeology. Curiosity is the fuel that is going to drive you forward on this journey. If you do not have it, you are not even going to get started, or you're going to peter out as soon as it gets hard. You have to be curious about what other human beings were trying to do with the code that you encounter. You need to ask yourself questions like, who wrote it? Why did they do it? Why did they do it the way that they did it? What's the story of the writing of that code? And what was the story of the code after it was actually shipped, after it was written and delivered and developed? Like Layla implied this morning, asking these questions is a very important part of what it takes to be a developer. That's an important part of the value that we actually bring to this process. So how do you cultivate curiosity? People have actually asked me this question since I read a lot about brains. And it's distressingly simple, actually, how easy it is to actually get curious. Unleash your inner 3-year-old. Just start asking why over and over and over and over again until it sounds really annoying even to you. Why is this way? Well, because this. Well, why is that way? Well, because this. What about this? Oh, well, why is that? You just keep continuing on until everyone is exhausted. This process is exhausting, no matter which side of it you're on. It takes energy, and that's part of why that curiosity is the fuel that was going to push you through this journey. But this practice will help you develop a habit of curiosity. If curiosity is your fuel, then empathy needs to be your guiding light as you go along this process. If you assume that the person that wrote that code was an absolute blithering idiot, stupid, ignorant, or lazy, then you're going to run with that assumption and you're never going to find out anything real about why the system is that way. Why does your brain do that? It's this nasty thing called the fundamental attribution error. And the fundamental attribution error works like this. I overslept due to insomnia. I had a poor coffee experience, right? I'm frustrated by this poor coffee experience I had. I am overwhelmed by work stress. But you are lazy, angry, and sloppy. The fundamental attribution error says that your behaviors are a result of the situation that you are inside of, that you are surrounded by. But other people's behaviors are because of intrinsic attributes to themselves. It's a nasty little trick that your brain does. It's probably my favorite cognitive bias, which is an extremely weird thing to say out loud, but it's true. Empathy is going to have to help you get past this. And I've been the person who was unempathetic. When I was working on that bingo project, the things that came out of my cube were not kind nor empathetic. In fact, I have a coworker who actually kept a notebook for a while of the stuff she would overhear coming out of my cube. She claims to have lost it. I don't think she did. I think she just doesn't want to show me. I know firsthand the tendencies that we have when we approach these projects, all right? So that's why I'm here to try and help you through it. It helps to have what's called beginner's mind. Beginner's mind is this concept that you start from the assumption that you do not know. As they say in the Zen parable, you must have an empty cup. If you start by assuming you don't know why someone did this and reminding yourself you don't know, your brain's telling you do, but you don't. It helps you be empathetic. The Agile Prime Directive says, regardless of what we discover, we understand and truly believe that everyone did the best job they could, given what they knew at the time, their skills and abilities, and the resources available in the situation at hand. It really only says this about the context of retrospectives. You need to have this thought all the time. This needs to be basically your ethos as developers, reading other people's code. Which is to say, you need to start closer to Chesterton's fence than to the monkey ladder. If you want to get better at empathy, a quick way to do it, well, not quick, but an easy way to do it, is starting with gratitude. Gratitude journaling, which is a real simple thing of just taking something every morning and writing down something you're grateful for from the day before. Sounds dumb, has huge benefits. A lot of things for the brain work like that. This can help you be more gracious, which helps make you more empathetic. You can also try doing your archaeology with other people in a paired setting and help keep each other accountable to being curious and to being empathetic. Now, this is a thing that even archaeology and anthropology itself is not always good at. There's a joke out there that goes, how does an archaeologist say, I don't know? And the answer is for ritual purposes. A couple of people laughed. Thank you. Archaeology and anthropology is often reached for these assumptions that people are simple or uncomplicated or unintelligent, and so they're doing these things that we don't understand, and if we don't understand them, they must just be rituals, right? This is actually a photo taken from a exhibit in the Museum of Science in Minneapolis, Minnesota, which I visited recently, and I was excited about it because they actually had a section next to it that said, "We don't know what these are." And I was happy about that, like for that industry to turn around and say, yeah, we just don't know. They were in a hole, we found them there, ? Is important. And actually it's interesting because they actually turned around and said at the bottom here, perhaps the tools were buried as an offering for rain and successful harvest. Like they can't even stop themselves. That's how strong this narrative drive is in your brain, in all of our brains. Front-loading the mindsets of curiosity and empathy is going to help you before you even open the first file of the code base. It's going to set you up for future success. Because sometimes, all the code you're going to write is somebody else's legacy code. And sometimes, the idiot that wrote this is you 6 months ago. Once you have the mindsets in your head, we can move on to surveying. Because the odds are you're not doing this just for fun. You're doing this because you want to change the system. Right? Because somebody has told you, hey, this needs to work, or it doesn't now and it does need to work, or this thing needs to behave differently. if you're going to change the code, it helps to start with, where's the code at now? It's tempting to try and understand the full system at once. That's not going to go very well for you. You cannot fit it in your head all at once, all right? It's functionally impossible for any software of meaningful size. You can't even hold large sections of it in your head at the start. It just doesn't work that way. What you need are abstractions. Abstractions are the things that let your brain start to hold large, complex systems in itself, in your working memory, which we'll talk a little bit more later. Unless somebody else has documented these abstractions for you, you're going to have to uncover them as you go. To do that, of course, requires there to be abstractions in the code or patterns in the code. Sometimes those aren't there. But most of the time there are, because if you're working on something that large, they kind of creep in naturally because we need them to survive. As you navigate through the surveying process, you need to understand three things: the humans, the system, and the code, listed in kind of order of decreasing scope. But it's not really a monolithic process where you just move from one to the other. I like to think about it as more of an hourglass. You start at the top with the humans, work your way down to the code, and then kind of back up. So let's walk through each of these levels in turn. Start with the humans as they are currently. Your first goal here is to understand, why does this application even exist and who is using it and why? Ask yourself, what was it created to achieve? What types of humans use it? What are those people's roles? What are the goals of each user or of each role that uses that system? And if you're sitting there thinking to yourself, that sounds like user experience research, you're absolutely correct. It's basically what you're doing. The gut level human response to that, or developer response to that, is, but I don't wanna. What if I just wanna sit and read the code? Well, tough nuts, that's not how life works. And again, like Layla said this morning, the code is ancillary to almost what we do. We're solving problems, that's our job. You can't understand the code without understanding the humans first. So your output for this stage should basically look something like this: a set of roles in your system and the goals that they have when using your software. You can stay pretty high level, but it really helps to have this concrete. It's not going to be complete. You are going to discover things as you go through the code and say, wait a minute, that means they must want to do this. Or at least somebody told the previous developer they want to do this. So this is fluid, and it should stay fluid, but it's something that you can start to work with. The next goal is to explore the entire system of the application as it is currently. What are its parts? Where do those parts run? What are they written with, in, on? What tool chain is developed to actually be working with these things? Which parts talk to which other parts? And how are those parts built? What is the build chain, the tool chain that gets them to where they need to go? Yeah. This is pretty much architecture. But I don't like to think about it as architecture because it's almost easier to start from the bottom up in these cases. When somebody gives you something like this, which happens to be the map of the bingo system, the architecture map of the bingo system, one, this is wrong. There are a number of things incorrect about this. We built this not that long into actually receiving the system as we were working through it. And now, coming back to this after many months of having worked on it, I know exactly how this is wrong in very concrete ways. But it was close enough to get us what we needed at the time. All of these documents are going to be mutable over time. It's not helpful to think about it as architecture because realistically you don't care about the overarching vision. And in a lot of cases, as I'm sure everybody has experienced, a top-down architecture is not what the code actually is built like. Code is built from the bottom up, no matter what the architect says it should be done. And so a lot of the architecture is the architecture as is and not the architecture as we wanted it to be. Now you can start with the code. All right, that seems simple, except usually code is not very easy to start with. Where do you begin? Where do you actually start working with this thing? And the answer to that question is feature slices. As you move through, Pick something, pick some goal from some role inside of your system. Just start there. It may have been picked for you. If you're joining a team and they hand you a bug, or if you're a contractor starting on a thing and the client says, this doesn't work, congratulations, you've got where you need to start. Otherwise, kind of pick something that is close to the main purpose of the system, the reason that that whole thing exists, which in this case is to make money off of people buying bingo tickets. Once you get that and you have it listed, start there. Start with the first component that that user role is going to interact with, and begin there. All right, that could be an endpoint in an MVC system. That could be some kind of controller or page on a web app. That could be a physical piece of hardware. It doesn't matter, but start at that point. Now, just read the code. Sure, it's that simple. Very easy. Yeah, it's not. Brains are hard. Reading is hard. We as an industry do not spend enough time teaching people how to read code. So I thoroughly recommend this book, The Programmer's Brain by Félia Hermans, where she goes into great detail about the difference in your brain between your short-term memory, your working memory, and your long-term memory, and how things get from your short-term memory to your long-term memory, which is learning. As we read through code, we have to process it. It has to go into our short-term memory. We have to move it around in our working memory, and then we hopefully want it to go to the long-term memory. Otherwise, we're just going to have to repeat that process. Lesson, I wish I could spend all the time on this book, but we're going to just pick 3 short lessons from it. The first lesson is one about chunking. How many people have ever heard of the thing where you can only remember 7 plus or minus 2 things at any one point in time? Most of the audience. A lot of people have. This is your working memory, all right? It's the number of kind of slots that you have to juggle. And it varies depending on person. But those people that can do things like memorize huge swaths of pi or perform other fantastic memorization feats don't do it because they have more slots. They do it because they chunk. They break things down into similar groupings, and then your brain can remember those. So as an example, this is a piece of code from the Kino application. Don't worry about it. You shouldn't be able to read it. But the point is, you see how it's similar, right? There's a structure there. If we zoom in on it, you can see that a lot of those things are actually fairly similar. Now, there's differences between them. But if you want to break this down, right, if you look at this, right, you have to go through each piece of this if-else, and you have several lines of code. And you're going, okay, that one does this one does this one does this, etc. This whole process requires spots in your working memory. So what you can do to simplify things is literally just refactor. All I've done here is basically do the extract method technique. But now, where you had multiple lines of code, you have one. This is the power of chunking, the power of abstractions. This is what your brain wants to do. If you have a symbolic view or symbolism view of the brain, rather, a computational view of the brain, this is category theory. Your brain groups things into chunks and goes, all right, I can deal with all that as one thing. The coolest thing about this is you don't have to commit this code. Or you can, but then you don't merge the branch. Make changes as you go, which is lesson number 2. Do your refactoring as you read the code to make it easier for you to read the code. Not because it's better, but because it's easier to read. That lets you then turn around and say, okay, I can actually make more progress with this. The third lesson out of this book is replace unfamiliar language constructs. If you're rolling along and you encounter, say, a ternary, and you're not a ternary operator, and you're not very familiar with those, rewrite it. Do it as an if-else chain. Because what you're looking to do here is have your brain have the easiest possible path, the lowest friction to reading that code. And so if you're unfamiliar with those and it takes you a minute to process each time, refactor it into a thing. If you don't really understand switch operators for whatever reason, because they're not very common, refactor it into an if-else, or refactor it into switch if you think it makes more sense. Again, it doesn't matter if you're not trying to make this merge back into the main code base. As long as it's for you, do whatever you want and then pitch it once it's no longer useful. So from that point, you can now actually start to read the code. When you're moving through this first component, when you encounter a boundary, something where it transitions out to another component or a database, wherever, note it and move on. Don't make that jump yet. You're only focusing on that first component. So, for example, with the bingo system, The bingo system starts with a custom writ application launcher, which reads a file, a configuration file, which then goes and actually has a query processor. The query processor proceeds to then have a query processing thing where you can see that it is grabbing a particular kind of transaction type through this incredibly complicated and overwrought annotation format. And then it proceeds to actually go through and do a process here where you can see it's doing the myContext command timeout. It's setting up a myTerm object through this myContext and then submitting the changes to the myContext. I like this example because you can also tell that despite the fact that it is C#, the previous programmer was a Visual Basic developer. That myContext is a dead giveaway, right? We'll talk a little bit more about that later. Once it's from that, this is the data, the frickin' XML that describes the database format, and then from there we go into the database, and we just note goes to database, and we move on from that. This is a walkthrough of a single component, a single path from a single component for a purpose, right? In this case, it was for writers, bingo writers logging on. Now, once we've read the code, we head back up to the system. And this is when we start to follow that code around. All right, it called out to here. What was it doing? Let's go read that component. All right, it called out to here. What is this one doing? Proceed through this process, chaining from component to component to component as you go. The tool that you should be really using here to make sense of this is called execution flow diagrams. There's a bunch of different guides online, but execution flow diagrams let you actually show this thing is calling this other thing, and then it returns after a certain point. You can actually show a bunch of complex interactions. This one's not super complex, but you can show things like callbacks, etc. And they will let you go, hey, this is how the flow happens. So for the bingo app, this is the writing of a ticket, a bingo ticket. And in this case, you can actually see that the first thing we deal with here is a writer. It's not even a system. That's another human being. The player is going to place a bet. Writer is actually going to enter it into this terminal. That's going to flow through all of these things. It's going down to the database, back up, and then back down to the database. And then eventually, it hits a printer, a physical printer that prints a physical paper ticket. This is an execution flow, right? This is the path through that system. The next step and the last step in this process should be the humans. Once again. And the question you want to ask here, what is the eventual output or outcome of this action? They did something. What happened to the system as a result? Does that achieve the goal that they had when they came into this process? Why do we need all of this, right? We have spent a lot of time doing this. The core point here is that you cannot trust the code to tell you what the code should be doing. In a lot of cases, you can't even trust the code to tell you what the code is doing. Because in some cases, it's buried in other places. Oh, this is calling to the database. That should be easy. 10,000 lines of stored procedure later. Every little bit of information is context that helps you read this code better, contextualize it better about what was the intent, what was the drive, both the intent of the role and the intent of the person writing that code, because those two things can be different. Your goal for surveying is to understand what the system should be doing, what is the human goal here, and the output that we're looking for, versus what the system is doing. What is the code? What is the system performing, and the actions therein? Now, I want to be clear. If you stopped here, that's actually still super valuable. You've done a ton of work. You've dug up a bunch of information. And this, by itself, will still help you understand, oh, this is the lay of the land, and this is where it's different. But while it is tempting to stop here, we really should keep plowing forward into excavation, because if we know how the code is now, how was the code? What did it used to look like? Why is it the way that it is? To know why it is the way it is, we have to understand how it got to how it is now, what the process was that shaped it into the form it is at the moment. Great. How do we get that? Well, the answer is pretty short. It's history. We want to dig back in through 4 different types of history. Written history, oral history, version control history, and then what I call external history. Written history is pretty simple. This is documentation, all right? If you have it, congratulations. Step on the light. If you have documentation and it is correct and up to date, I'm sorry to be the one to tell you this, but you're living in a simulation and somebody's experimenting on your brain. But even if it's incorrect, which is most of the time, documentation can still be super valuable because it tells you a lot about why the code is the way it is, what they were intending as they went through this process, what the purpose of that piece of code is, or what the feature's purpose is, maybe even a little bit of how it got that way. Your ticketing system is also history too. If you're working on a ticket, that ticket is almost certainly, if you have anybody at like a project level, they probably have several, stair-step words of tickets. Like this ticket is then, it's an implementation task on this ticket, which has this overarching epic. People get paid to do that. It's hard work. But it's hard work for me. I hate Jira. But if you also hate it, know that it is still a really valuable resource. That process of chaining from ticket to ticket can get you to a place where somebody actually explains in plain English what the whole point of all of this is, where you're only seeing a very tiny piece. If there is not documentation, you should be taking Felia and Ermans' device and building it as you go. I'm not going to pretend that making documentation is easy, but if you don't have anything, starting to just jot notes about this is what this piece is, this is what it does, this is kind of the code flow through this, it'll help you out later. There's also oral history. If you don't have written documentation, you're not entirely out of luck. Teams often have an oral history of the project that everyone carries around with them in their own heads. In fact, sometimes you can find people who are like almost designated oral historians for a project because they've been there for the longest time. Lean on those people, all right? They may not remember individual specific pieces of code, but they are almost certainly going to remember large-scale refactorings in library switches, changes, etc. Those are things that are going to stick in their heads. The problems that they have, the weeks they spent on this one particular bug, and that's why this is dumb and stupid, yeah, that's going to stick right in their brain because we remember pain points because we don't want to encounter them again. As an example, a different project that I work on, not the bingo one this time. This one's for back-of-house restaurant management. This was a project that I was given. There's a toolkit called a KDS, a kitchen display system. If you've been to a fast food restaurant and you've seen those monitors that look like they came out of 1980 where they have like the columns of different things, and you can see the orders kind of move from column to column, that's a KDS. Now, we were building a report for our customers, and they wanted to know the difference in time between this KDS and this KDS. And if you look at this schema, some of the stuff doesn't make sense. They've got a view ID, what's a view, what's a transaction, what's a terminal number versus the view ID? I don't understand that. Where do I get the time? There's like 6 different times here. I went and asked the tech lead, and the tech lead said, oh yeah, it's this. This is what this is, and he points me to this entirely different table where the IDs actually mapped from what the customer sees to what we have as internal. And he explains, oh, you want this last bump time because that thing on the KDS that's like there's a bar you can hit that will move it to the next terminal when you're done making it. That's a bump bar, so that's the last bump time. All of that in his head, nowhere in the tickets. Not his fault, that's just software. Even non-technical folk can actually help you here. The product owner probably remembers that extremely problematic conversion, all right? Or the Scrum Master remembers the endless parade of tickets that it took to do that migration to the cloud. There's also version control history. Git remembers everything, whether you like it or not. And if you learn to use your version control effectively, you can generally almost find out exactly what changed and maybe even why if they wrote good commit messages. The place to start with this is generally in your IDE. I happen to use WebStorm a lot. They don't pay me, so, they can if they want, but this is what I use. Generally, every IDE is going to have what they used to call blame and now call annotations, where they show you this is who wrote this and the commitment that it went in on. Generally, you can also click it, and it will bring up the view there on the bottom where it shows you, all right, this is your commit in that flow of commits, and here's the commit message, and here's the other files that were changed in that commit. You can start here, moving through, looking at the actual annotations, and then proceeding to go, all right, what commit was that made in? What other commits have touched this file and walked backwards in time? Once you start doing that, I find it helpful to have an external tool that does a little bit better visualization. This is GitKraken, also what I use. Also, if you want to sponsor, feel free. But the benefit here is that it's just a better visualization. You get more screen space, and it does a better job at showing you that flow of commits through time. Branching patterns as well can also tell you a lot about how people worked. If you see people making branches, a couple commits, and then making a merge back, they're probably using something like git flow or some other common methodology that involves branching. If you see people making commits only to a trunk branch, but you don't see people interleaving functionality next to each other, then they're probably using something that is branching, but they're squashing it. If you see people interleaving things, they're probably using some kind of trunk-based development. It doesn't matter what they used, it just helps you understand, oh, this is the process that shaped this code. While we're talking about it, I would like you to be kind to future archaeologists, rather i.e. yourself, and have a good commit history, please. WIP, it does not tell me anything about what you were doing, other than that you were pretty frustrated by it, probably. Please work now also does not tell me a lot about the implementing of the code. It tells me a lot about what you were thinking at the time, but that process of writing those things is valuable to you, and having a clean commit history that actually tells you what was going on, not just the what. Please don't tell me what changed. I can get that. Tell me why you changed it. Tie it back to a ticket, tie it back to some functionality, because this. The last kind of history is external history. An external history is the history of the things that shape your project. It's probably, you can understand it if you think about it. External projects, frameworks, libraries shape your code. They change the way you write that code, especially if it's a large-scale framework. And you can actually tell things about your code because of the libraries that you work with. Anybody remember Flux? If you've done a lot of front end a long time ago, I saw somebody raise their hand. This was a library that got reasonably popular until it was completely subsumed by this other library, Redux. And Redux's whole deal is you have this process where you have this global state store that the view is selecting from, and then the view is actually enacting actions that go out, and potentially in some cases they're getting subsumed by middleware that is calling out to API, but in all cases they're coming back and mutating that state, which is getting reselected back out to the view. This is an extremely complex process, and it actually has a tremendous effect on your code base. If you're using Redux, you have a ton of boilerplate code. That's just how it kind of works out. It's not bad, it's not good, it just means that using this library shapes that. I was actually explaining to a junior developer why all of this exists. And in some cases it exists because Redux wanted us to be able to do time travel debugging, where all of these actions are idempotent and we can move backward and forward through time, and the user can have an error and then the browser will automatically send us the event list. I don't know about you, nobody in my company ever used that. But the choices made as part of that process to achieve that in the framework have effects on our code bases. And that's true for every library we use. Their goals affect your goals. As you go through these processes, you might actually be able to build out strata of your system, depending on how old it is. So, for example, the back-of-house restaurant management software has 4 kind of distinct strata. It has an ASP.VB.NET strata, it has a brief backbone marionette strata, it has a JavaScript React Redux strata, and the most modern strata is TypeScript React React Query. All of these exist in the same application. Yes, they're all running. Yes, we do use all of them. We're working on getting rid of the old ones, but that's the reality of code. You generally don't have time to go back and fix everything. So I think about them like this, right? They're geological eras in that matrix around the artifacts in which you're extracting. The presence of an artifact in that layer tells you how old it is. It tells you something about what the methodologies were that around that time. These are an essential part of establishing kind of a story of the system you're working with. So, second to last step is analysis. You're going to be reconstructing the story of what happened. And that might seem easy because our brains are primed to tell stories. You almost certainly already have a story as you've gone through the work, the story of what happened to this code. That story is almost certainly wrong. It is riddled with assumptions and biases and errors, okay? Now, to be clear, your goal is not to find out the true story. That's likely to take way too long and might actually be impossible. There's usually a lot of gaps in the documentation, in the histories that we work with. Your goal is to find a story that is better, that is less wrong, and thus more useful than the default one which your brain is probably screaming at you. How do you manage that? We've got a subset here. A couple different steps, the first of which is flashing out the cast, determining conditions, looking for similarities, and divining intents. So we're analyzing the code by doing all of these. The first is fleshing out the cast, working through the developers on the system. Who were or are the people involved in writing that code? What are their tendencies and habits? What are their tastes? Like we saw earlier, there was a developer who was still prefacing everything, even in C# with my, because they had learned that doing Visual Basic, because that's how you did it in Visual Basic. Maybe Claire on your project likes writing code that is extremely well organized and well engineered, maybe a little too well engineered sometimes. Or maybe Howard is very focused on completing tasks, sometimes more focused on completing tasks than on the engineering. Understanding what's driving the humans who wrote that code helps you understand where they're coming from and what they were trying to achieve when they wrote it. And that actually goes for people who didn't write code at all, too. The non-technical people actually did shape the project. The people doing the work of assigning the work, fleshing out the work, testing the work, although QA people are technical people, all of those people are still part of this process. And what they believe, their tastes, their preferences, also shape the work that we do, because software is collaborative. It's just harder to get information about those people because they don't have a Git record. The next thing you want to do is determine conditions. What were the situations surrounding the writing of that code? Maybe just the whole system, maybe just that piece of code. How did those decisions, did those situations shape the behavior of the team? If a team is in crunch mode, they're going to make different decisions than if they have adequate time and effort and energy to put into thinking through things. What resources did the team have? What resources did they lack? What strata is that code from? What now commonplace solutions and processes just did not even exist at that point in time? What were the organizational rules and processes? And what other projects were going on? Because those things can suck energy away from other projects. If the thing you're looking at was a thing that people put time into only when they were, say, on the bench at a contracting company, that's going to shape it in a very different way than if it was something that people were constantly spending time and energy on. So, as an example, I would like to prove how old I am. This is backbone marionette code. If you look at this with a modern JavaScript eye, it looks awful. There's all kinds of weird things. One, we're using like this. That's not great anymore. That's not the style. We're using all of those nested, like the dots on the controller, and then referencing it over and over and over again. Believe it or not, this code looked real good back in the day. This was how you used to write JavaScript, and it was considered to be that, not quite the epitome. I'm not going to say it was that, but this was good code. But the processes have moved on. The circumstances, the situations have moved on. You're also looking for similarities. All right? It's not a stretch to say that we just don't have enough time for anything. And in fact, unfortunately, any work we're given is likely to expand to fill the time that we give it. Also, software is really hardly a scientific exercise most of the time. And so when we come up with the solution, it's not likely to be the most scientifically correct or the most efficient solution. It's just a way that worked. But the problem with the human brain is that we often do things in the same way that we have done them before, or at least that's the first thing we reach for, because we don't have time or we don't want to spend the energy to go find that optimal way. That's not bad. That saves us a ton of time and energy most of the time. But it means that we tend to do things that are similar to what worked previously. We also confuse familiarity with correctness or rightness. That means that when we see something familiar, we're like, oh, this is clearly good. So, While you can't make any guarantees, if you encounter a piece of code that was written after another piece of code, and those two pieces of code look similar and they were written by the same person, they probably patterned one off the other. Actually, if they were me, they copied pasted one and just straight up modified it, because that's faster and easier and more less energy than trying to rebuild everything from scratch. Why would we do that? That process can actually also be completely subconscious. So I worked on the back of house restaurant management on a data warehousing problem for them. And they had a basic, like a nascent one that they'd started to set up, where this was one of their primary fact tables. That fact table had a couple associated fact tables that were relationally associated with it. And if you have done data warehousing, you should go, wait a minute, that's not generally the right way to do it. And it's not. But these tables looked exactly like the materialized tables that this previous developer had written to speed up previous queries. What had he done? He'd taken those other ones, copy-pasted them over and said, sure, that looks like data. It's not that he didn't know what he was doing. It's that he hadn't had the right education necessarily to understand that it should be a broader, wider, they call wide columns, or wide tables. The last thing you want to do is define intents. The most important thing, arguably, is defining intents. Finding out what were the goals of the person that wrote that software. What were they trying to achieve? Changing things is so much easier if you understand that. You're trying to figure out, is this a monkey ladder situation or is this a Chesterton's fence situation? So now you have the cast, you have the backstory, you have the conditions, you have the code, you have everything you need to sit down and write a story that, again, will be wrong, but it's better than the one you had out of the gate. Remember, be curious, have empathy. They almost certainly did not want to write bad, awful code that didn't scale. Now you can focus on progression, moving on. Maybe even just from a tiny piece of that code. So what do we do about it? Or why did we do that, rather? Like, we've spent hours and hours and hours of work on this. Well, we did this because, if you remember right, we wanted to change something about the system. Some piece of code that was wrong, and some outcome that was wrong, and we're trying to find it, right? It's easy to lose sight of your own goals when you're thinking about everybody else's goals throughout the course of this project. So it takes a moment, or it helps to take a moment to just sit back and say, okay, this is what I'm trying to do, is to get this to look like this. But once you've understood how the code, or why the code is the way it is so much easier to understand how to change it. You can actually give answers now to questions like, if the previous code was constrained, are those constraints gone? If the code is affected by similarity to previous code, should it have been similar? Was the person's intent incorrect when they set out? Or did the world shift underneath them, and only now is that intent incorrect? What strata is the code from? What does that mean about where that code lived, how it was built, why it was written the way it was written? That story should be your bedrock, the basis of all of the changes you make going forward, for all of the future work on that code. If you understand why the code is the way it is, you can understand how to change it, to make it be the way you want it to be. Or whether to blow it up entirely and to start over. The rewrite refactor decision is extraordinarily difficult for developers, and I've been on both sides. But most of us look at rewriting as this horrible thing where, you're going to encounter all of these bugs, these things that you didn't know about, these edge cases that didn't. You can find those if you go look at the previous code. Knowing why they did things, that this piece of code isn't just bad, it's this weird edge case that only happens on alternating Thursdays under a full moon. This information will help you make this call, whether it is time to rewrite or not. If you decide to simply refactor and go forward with the code, these are a bunch of resources for it. You can either grab a picture now, or actually the bit.ly will have a link to my speaker deck, and that has a full list of all the resources I mentioned in this talk. But Emily Bocci's talk, her talk on refactoring guided learning, is very good. I haven't read Refactoring to Patterns yet. I've read the other two. And despite the fact that Refactoring by Martin Fowler is the book that coined the term refactoring, it's still very good. on this process. Also, write down what you figured out, okay? You've just done a ton of work. Please start to write that down, okay? Consider it a favor to future developers. Consider it a favor to future you. Again, I'm not going to pretend that documentation is easy. Storing this in a way that makes sense is not, it's literally an entire discipline called information architecture, all right? We could spend another hour talking about that, more than an hour. So I'm not going to say that it is easy, but start trying to find somewhere to put it in a way that makes some kind of sense. Because otherwise, somebody else is going to have to come after you and either come and ask you about it because you've got it in your head, or build all of it on their own again. So, what could we do with all of this tomorrow? Well, start documenting your system. Don't treat it as an individual effort. Treat that as a team task. If you have zero documentation, literally just start by everybody's first task on a ticket is to write a little bit of documentation about the system, the part of the system they're touching. If you're deciding about things, making decisions as a team, using architecture decision records is actually another really good choice. And architecture decision records, actually I don't have a resource for that, I should find one. They're a tool that will help you document how and why you made decisions. You can actually start practicing curiosity and empathy tomorrow. Well, whenever you go to work next. Those muscles grow stronger as you use them. The more regularly you pull those to the front in your brain, the more you will reach for them as a tool. When you encounter code that you don't know what it does, you've never encountered it before, start walking through those phases. Practice the phases like the mindset, surveying, extracting, analysis, and progression phases. Maybe do it as a team. Grab a partner and do that together. You do not need to exhaustively work through all of the old code in the system. Just focus on, we're working on this particular bug, this particular piece, and start there. You can also start building an acknowledgement of this effort into the things that you do, into your pointing, into whatever estimation or planning process that you happen to use. You do not want to make this kind of archaeology hidden work. It probably already is if you're doing any of it. And so pulling that to the front and explaining that this is difficult and it takes energy and time can help you get a better realistic picture of the tool, or of the timing rather, that it's going to take. If people are skeptical about it, make sure you start telling them when you find the past stories useful. Oh, I spent a day on this, then it took me 5 minutes to change this. And every time we touch this now, it'll only take 5 minutes. The value you provide as a developer is about the things that you can get done for the user. People are using our software as tools, right? They have a goal, they're using it to affect change on the world. If you cannot help them do that, then we're not writing software that is any good. We're just writing piles of miserable code. So let's sum up. These were the phases: the mindset, surveying, extracting, analysis, and progression. For mindset, remember, start closer to Chesterton's ladder than to the monkey fence. Build your curiosity daily and practice empathy toward those who wrote that code. For surveying, start with one user goal and work your way through the hourglass: the systems, the human, the code, and then back up. For excavation, find the forces that shape that code's creation and look through all of the histories available to you, and opinionated external libraries as well. Establish strata when the system has actually lived long enough to have them. For analysis, flesh out the characters, find the backstory, and write that play. And lastly, for progression, recontextualize based on your own goal. What were you trying to achieve? Should you rewrite? Just refactor. Use that story to guide your next steps and write down the things you found. The temptation to believe that every other programmer is an absolute blithering idiot that does not know what they are doing is extremely strong. Trust me on this one. But if you can figure out how to engage in code archaeology effectively, that can unlock an entirely different way to engage with code, to think about, to read, and to process the thing that we work with every day. And that can dramatically increase your power. Thanks everybody very much for listening. The slides are up there at that bit.ly, and like I said, the resources are actually all up there as well. If you got questions, I'll be up here.